In section 6.6, we introduced the non-isolated system. Here we want to identify and understand various means of transferring energy and also understand the law of conservation of energy so that we can use this to solve problems. Now, let's start by making sure that we understand what we mean by the term non-isolated system. A non-isolated system are problems where the system is going to interact with its environment, causing some sort of a change in the system. This would be a particle experiencing some sort of outside force that causes some sort of change in its velocity or its kinetic energy. Work is one means of energy transfer and has the effect of actually transferring energy between the system and the environment. So doing work on an object is a way of transferring energy to or from the object itself. Now, if you give that object more energy, then that would be doing positive work on the object or on the system. If you're sucking energy out of the system and the thing turns up with less energy than what it started with, that would now mean that negative work is being done on that system. So positive work means energy is transferred to the system, and negative work means that energy is transferred away from the system. So far, we've only looked at one type of energy in a system. That was kinetic energy that we introduced in the last section. But let's argue another. Picture a book that's sliding across a carpet, and let's choose the surface or the carpet as the system. So here's our carpet down here. We have a book sitting on it, and we're going to slide this book maybe off to the right. Now, the book exerts a frictional force on the surface in the direction of the motion, and the atoms on the surface are going to slide slightly in this direction. If you picture this as a shaggy carpet, the carpet fibers maybe started out like this, but when you drag the book across it, now they're kind of angled like this, right? So we do in fact have a force that's being exerted on these particles or fibers in the carpet, and we have a displacement of those particles or fibers. They were dragged to the right a little bit. And since the force and the displacement are in the same direction, that means that positive work was in fact done on this system. But we can look at that carpet and notice that the kinetic energy of those carpet fibers is not increased. So does this violate our work energy theorem? No, it doesn't. It's just a misapplication of it. The work energy theorem requires only a change in speed to be occurring in the problem. If work in this case did not change the speed of the carpet fibers, then what did change? So it didn't get any faster, but something did happen, and energy was input into this system. And in fact, you've probably guessed it, it's the temperature that changed in that system, or what we call internal energy. Internal energy is basically just heat. So because you drag the book across the carpet now feels just a little bit warmer for having that force and displacement or that work that was done on it. So work did in fact transfer energy, just not as a kinetic energy, but as an internal energy or heat. Let's look at some of the ways that energy can be transferred and look at the total idea then of conservation of energy. There's many ways to transfer energy into or out of a system. Work is one of those means. That's the application of a force and some sort of displacement that's occurring. But we could also look at things like mechanical waves. This would be some sort of disturbance that propagates through the medium, like sound, a seismic wave, an ocean wave. Those are also means of transferring energy. Heat is another. Heat are those microscopic oscillations or collisions. Basically, the more the particles are bouncing around within an object, the warmer that object is going to be. So you have that thermal conduction. These are fast-moving objects that collide with the slower-moving ones and then propagates that temperature increase. Again, another means of transferring energy. Matter transfer is another, where matter is physically transferred across a boundary of a system, carrying energy with it, like filling your car with gasoline. Electrical transmission is another means of transferring energy. This could be an electric current. When you plug something into an outlet, like a stereo or a hairdryer, you are now transferring energy through that electrical transmission. Also, electromagnetic radiation. Electromagnetic waves also transfer energy. These could be light waves, such as microwaves, radio waves, and anything along that EM spectrum is again a way of transferring energy. Now, what we know in the universe is that there seems to be this law of conservation of energy. We have never seen this violated in nature, that we can neither create nor destroy energy. If an amount of energy in a system changes, it's only because energy has crossed a boundary by some sort of a transfer mechanism. So total, the energy has to be conserved. The only thing that we can do with that energy is transfer it. And so if we look at the total change in the energy of a system, that change has to be equal to the sum of all the transfers of energy that have occurred. So again, energy cannot be created or destroyed, just transferred from one place or another. So looking at this total change in the energy of the system being equal to the total sum of the transfers is kind of like balancing a checkbook. When you want to look at how your checkbook has changed in some sort of way and the amount of money that's in there, you need to sum up all the transfers, everything that you've put in, along with everything that you've taken out. Energy works the same way. When looking at a system, you need to look at all the energy that's being put into the system, as well as all the energy that's being taken out of the system. Now, if all of those transfers are equal to 0, then we would call that system isolated. If the sum of the transfers is not equal to 0, that's what we define as a non-isolated system.